Welcome to another day on the Journey Chez Chem. Please do the 2 warm-up questions and you'll notice that the numbers don't come out exactly right and you cannot have a half of an atom. Therefore, you're going to have to multiply the number by some number to get both of the atoms to a whole number. So you give it a shot, do the best you can, and we'll go over it in a moment. In number 1, I'm given 6.27 grams of calcium and 1.46 grams of nitrogen. I always must change my grams to moles because that's our connector. That's how we can compare the atoms. Therefore, in 1 mole of calcium, the mass is 40.1 grams of calcium. And that gives me 0.1563 moles of calcium. And nitrogen, I must do the same thing. And 1 mole of nitrogen has a mass of 14.0 grams of nitrogen. And therefore, I have 0.1042 moles of nitrogen. Now, in order to make our comparison between the number of moles, I have to divide by the smallest number to get my ratio. And when I divide this by itself, I get 1. And when I divide this by the smallest number of moles, I get 1.5. And I cannot have 1/2 of a mole. Atom, excuse me. I cannot have 1/2 of an atom. I either have an atom or I don't have an atom. It doesn't come in halves or parts. Therefore, I must multiply them both by a number to get a whole number. And when I multiply 1.5 by 2, I get 3 and 2. So my empirical formula is calcium with a subscript 3 and 2 nitrogens. That's how you do number 1. In number 2, I have one extra step, but first I have to find the empirical formula. I'm given 8.87 grams of phosphorus, and again, I must change my grams to moles. And 1 mole of phosphorus has a mass of 31.0 grams. And then that gives me 0.2861 moles of phosphorus. And I must change my grams of oxygen to moles as well because I have to have them both in moles to make a comparison. I always, when is that? Always go to moles. So 1 mole of oxygen is 16.0 grams of oxygen. And therefore, I get 0.7143. Now this 0 is not significant. It's just to show you where that decimal is. Now I'm going to divide by the smaller number of moles. And phosphorus is my lesser number of moles. 0.2861. Therefore, I get 1 phosphorus, and when I divide this number, I get 2.49, which is very close to 2.5, and I cannot have half of an atom. So I have to find a number to multiply this by in order to get them both to a whole number. And I know that if I have $2.50, if I multiply it by 2, I'm going to get $5. So I multiply them both by 2, and I get P2O5 for my empirical formula. Now, in order to find the molecular formula, I have to find the mass of this empirical formula. I need the empirical mass. There are 2 phosphorus, And each phosphorus has a mass of 31.0. And there are 5 oxygens, and each one has a mass of 16.0. Therefore, I have 62 and 80, which gives me a mass of 142 for my empirical mass. Now, we're always given the molecular mass, and that was given in the problem. The molecular mass was 284, and my empirical mass is 142. And when I divide the empirical mass into the molecular mass, it goes twice. It's always going to be a whole number. So if you don't get a whole number, you might want to double check your empirical mass. Therefore, I take my empirical formula and I multiply through by the 2, and I get P4O10. This molecule actually has 4 phosphorus in the compound, not 2. Because I could not put a 2 in front. That would just say I had 2 of those formulas, and that is not the case. The compound actually has 4 phosphorus in the compound. And that's how we do that problem. Now, the only other thing I have, we need to talk about hydrates today. So I'll be right back. Hydrate formulas are done very similarly to how we did molecular and empirical formulas. And we are going to begin lab tomorrow, and you will first do the first one is on a hydrate. And we are going to take a compound that contains water in the crystals, and we're going to heat it up and drive off that water. We're going to evaporate off the water from the crystal to get the compound by itself. And if you look at worksheets that has the hydrates on it, I'm going to go through the example problem that's given to you there. You are given a 10-gram sample of the hydrated crystal. And out of that, then it was warmed up and heated and the water's driven off, and I'm left with 6.4 grams of the copper 2 sulfate. I weighed it out and I saw that after it was heated and dried, the mass was 6.4 grams. I changed those grams to moles. I always have to go to moles because that's how I make my comparisons. And 1 mole of copper 2 sulfate has an atomic mass of 159.7 grams of copper 2 sulfate. Copper has a mass of 65.6, and sulfur is 32.1, and 4 oxygens is 4 times 16.0, and when I add all these numbers up, I'm going to get the 159.7 grams. And we've talked about gram formula mass before, so that's not anything new for you. And when I do this, I see that I have 0.04007 moles of my copper 2 sulfate. Now, I know that I originally started with 10 grams, and of those 10 grams, 6.4 grams were my compound. The remainder from the 10 grams was my water, so I have 3.6 grams of water. And again, I must change my grams to moles. 1 mole of water has a mass of 18.0 grams of water. And therefore, I get 0.2000 moles of water. And just as I did before, I'm going to divide by the least number of moles. And this is my smallest number. I get 1 copper 2 sulfate, and I divide it into this bottom number, and I get 4.99, or 5 moles of the water. Now, the way that we write these hydrates is we write them with the compound as it originally was, and then we multiply by the 5 waters. If I added the water to the compound, I would not recognize this as being my copper 2 sulfate. I must separate it out, otherwise it would not be anything that we would recognize. So we always put a dot and the number of waters. It's very similar to what we had before. You have 4 problems to do this evening and also to prepare the lab for tomorrow. So I can't wait to see you, and I hope you understand a little bit better today, and we'll talk about it some more. Bye! See you tomorrow.